Hi everyone, Mr. Wickens here. In today's episode, we're going to talk about net force. And what net force is just the sum of all the forces acting on an object. In previous episodes, we talked about the different types of forces and how to draw forces acting on an object using a free body diagram. We're going to use those different concepts today to determine the amount of force acting on objects and what force means if there is a force acting on an object. So basically this came about because a long time ago people are thinking, what happened when a single force acts on an object? It seems like a really simple question, but it took about 2,000 years of people trying to figure this out, to actually calculate what happens when there's a force acting or multiple forces acting on an object. Okay, so net force. We looked at diagrams like the one down below before, and we called them a free body diagram. So if we have all these forces acting on this object in this free body diagram, we're going to sum up the vectors because they're all in different directions. If you recall how to sum vectors, it's going to require, in this unit too, we're going to have to use cosine and sine and arctan laws. But when we sum up all the different vectors, we're going to get this thing called net force. And so net force, like I said, is the vector sum of all the forces acting on an object. And for ease, just like we did in the first unit on kinematics, we're going to separate if we have vertical and horizontal components. So if we have x and y components, we're going to separate those components, add them up, and then we're going to make our fancy little right triangle to find out if there is an angle. Lots of times there's going to be zero force in the y direction. If you have a car driving down a road or a book moving across a desk, we're just going to use the x direction. Similarly, if you have an object falling, we'll just use the y direction. Sometimes we will need to use both though. So if we wanted to sum up some simple motions using net force, if there's no force at all, that means the net force is going to be zero. That one's pretty straightforward. The one thing that's not super straightforward about that is if you have no force acting on something, that means that there's a constant velocity or no motion. So it means the acceleration is zero, but even if the acceleration is zero, it means that something can still be moving at a constant velocity. Okay, if we have two or more forces acting on something and the net force is zero, it's going to be the same as before. You can have a constant velocity or no motion. Our acceleration is still zero if we have a net force of zero. All right, what if the net force isn't zero? If you have one force that's acting on an object, and then the force is obviously not going to be zero, you're going to have accelerated motion. And the same goes if you have more than one force acting on an object and the net force is zero, you're going to have accelerated motion. So you're going to have a changing velocity. And I think that when we talk about Newton's second law, it'll make a lot more sense. So if we want to practice this, we can look at these two different diagrams to figure out what the net force acting on the object is. So for A, we're going to add up the x and the y components to figure out what the net force is. So if we look at the y components first, we have 100 newtons up for the normal force, 100 newtons down for the gravity. So those cancel out. We have 0 newtons in the up and down direction. Now we look at the x direction. We have 20 newtons right of applied force, and we have 20 newtons left of friction force. So again, 0. So this object, the net force is 0, which means that is either not moving or it's moving at a constant velocity, but the important thing is the acceleration is 0. For B, we have an applied force of 70 newtons. We have a frictional force resisting the 70 newtons and 20 newtons. We also have air resistance, which is resisting the motion, of 20 newtons. So our total resisting force, or our force to the left, is 40 newtons. So 70 minus 40 is 30 newtons. Both those, I think, are pretty straightforward. So here we can calculate the missing values. So for A, we have, it says 0, there's no, so for number 2, A, we're going to assume that the acceleration is 0, so that this object in A is either moving at a constant velocity or not moving. So we have 150 newtons and 70 newtons up for a total of 220 newtons up. And if this object is not accelerating, then the gravity must equal the force up because we have a net force of 0. So our force of gravity is going to be 220 newtons down. For part B, it tells us what the F net and the x direction is. It says it's 3.2 kilonewtons. And if we wanted to translate that to just newtons, it'd be 3,200 newtons. Because remember, kilo means there's 1,000 of that unit. So we have, to fill in the blank, we have some applied force here. We don't know what it is, but we can figure it out. So we have 3.2 kilonewtons total, and that's acting in the right direction. So we have 0.7 acting in the other direction, which means to get 3.2, we must have 3.9 acting in the right direction. 0.5 of it is accounted for right here. So our F applied must be 3.4 kilonewtons. And that is how you kind of add up forces in a very simple way. We're going to do some more complex problems later to find what the net force is and what the net force must be. Again, if this video made sense, please leave a like. If there's some things you think I can improve on, please leave them in the comments. I'm always looking to improve these different presentations. Thank you. Have a great day. Bye.